within k stops. Okay, so let's read the question. There are n cities connected by some number of flights, and you are given an array flights, right? And within flights of I, from I to and price we have given. Okay, next it is saying that yeah, from I is given. Now what do you have to do? Three things we have: source, destination, and k. What do you have to do? Return the cheapest flight from source to destination with at most k stops, and the number of stops is given, right? Where is k? If not, we have the route, then what we have to do? We have to return -1. Let's see here in this example. Let's see, we have given what? N we have given in example 1, n equal to 4, and the flights are given like this: 0, 1, 100. So if we'll talk about this is, let's suppose this is our source from where we will start, right? So this is the node we have given first 0, it is going to 1. Okay, so this will take, right, 100 rupees flight charge. If this is the possible, I'll go daily to my home. Next, what we have, another route we have given, in which we have source is given 1, destination is given 2, and again it's charged 100 rupees. Means if someone is want to come from flight from here to this route, right? So he has to spend 100 to reach here, 200 rupees, right? But because see, we don't have direct flight from 0 to 2, right? And that's why he has to spend 200 rupees, let's suppose. Okay, next we have given 2 and 0. From 2 to 0 there is 100 rupee charge for return back, right? Next, again if you check 2 to 3, right, it is given 2 to 3, it is given this one 200, and 1 is remaining 1 to 3, right? 1 to 3, it's 600 rupees. Like these flight charges we have given, and one is source is given, another is destination is given, and one k is given, right? So we have to find the we can say minimum we can say cheapest flight, minimum charges, minimum cheapest price, and source to destination, and with at most k stops, right? So see, k we have given here what? 1. We have given k equal to 1. Now we have to check now what is the source is what we have 0, and what is destination is 3, correct? Destination is 3. So if someone want to go from source to what? This is the destination, right? Here, source to destination, right? This is our source, and this is our destination, correct? If someone is want to go source to destination, he has to go like this, right? So there is two way. Either he will go to what, like this, that I told you, from here to here, and then he has to come here, right? But see, this will take how many stops? First it will take 0, then it will take 1, then it will take 2, right? More than given k we have, right? So if he want to come from here to here, right, so he can directly come here from 1, this route he will check, and then he will come to here. So he has 100 plus 600, right? 100 plus 600 is equal to 700 charges he has. So this is the uh, that's why we are getting here. So let's see the explanation. What the explanation is saying: the graph is shown in the above. The optimal path with the at most k stops from city 0 to 3 we have given, right? At most 0 to 3, and that is marked in the red and has cost what? 100, and this is this that I told you. Note that the path through the cities 0, 1, 2, 3, 4, 3 is cheaper, but is invalid because it uses 2 stops, right? Uses 2 stops, and that's why we are not using this one. Okay, so let's see another example I also have, right? So if what is source is 0, destination is 2, k we have 1, right? So if someone is want to go from 0 to what? 2, right? Here, so he will take 100 and 100, he has to pay 200 rupees only, right? But if he want to come here, he has to pay 500. So 500 is more far than 200, and that's why this is 200 is the amount. First we have given what? Number of flights we have given
right, and the flights we have given. Okay, and see if the first one, where is the example? You see n is given, right? N is given means 0, 1 and 2, means total node we have given. N is total node, and so it will go to how many flights should be there? Now it should be 3, 0 to 3, if n equal to 3, right? 0, 1 and 2. For each pair there will be some what, a source, destination and its price will be given from each one. Okay, that's why we are having this value. So n we have, flights we have, source we have, destination we have, and k we have, right? So first of all, what we should do, we should maintain our adjacent map, you can say, in which we will take like this. See, this is the adjacent map, right? And say this is our we are taking list, right? So let's suppose if this is a list, so it at the integer, let's suppose we have node what, 1. Okay, just for example, this is the node. At this position we will take a list, right? How will the list will be look like this one, like this. Similarly, at this position there is a 2, node 2, right? So there will be a list similarly as like this. So if we re-represent this one, so it will look like how? It will look like this one. At 0 there will be a list of like this. All the neighbor node will come onto this list. Okay, like this. In the last you can also take one more. Okay, so that's why it is coming. There is an integer at this position, right? This is the map, right? So we will take at this map we have some value, we have. Let's suppose if I'll take the node, right? So I'll take node 1 and then the value, node 2 then the value, last n comma the list, right? So it will come. I think I've understood. Next time what happen, we will make a for loop, right? And then we will update this one and these values, right? So for each flight, let's suppose flight number 1, this is the flight number 1 we have, right? So for the flight 1, we will check flight 0 means nothing but our what, 0, right? So this will give what, let's suppose we have 1. Okay, and so it will come what, we will check the flight at 0 and flight at 1. uh, I think we have to take back down, so it will become flight 0 and then there is a, it will come flight what, 1, we can take 1 and 2, you can say. So what will happen if that there is no flight, right? So it will update its value. Okay, let me check. Yeah, now what we will do here, we will create our distance, right? So now what happened, this that I was talking about, this one, so this value will get updated, or all its value, right? The flights we have given, right? Let's suppose flight we have given, if we'll consider this example, uh, the first one. Okay, so first one is big one, so we'll take this one. Okay, so flights we have given like what, 0, 1, 100 we have given, right? Next time what we have given, 1, 2 and 100 is given. Good. Next we have given 0, 2 and 500 we have given, like this. So this is the row 1 we have given. Next we have given row 2. This is given row 3, right? Like this. And this is our nothing but what, look like this one as a 2D matrix, right? So we are say at this position, right? What we have, n equal to what, 0, then we have 1, then we have 2, right? Like this. So for each one we have like this one, right? So we have to represent like this one only. Okay, and so that once we have our these representations, right, we will take like for 0 what we have, the what are the destination we have, so we will look like this one, right? For 1 what we'll have, like this. Then 2, what do we have, like this. And this will be nothing our map, we will put into map, and this will say what we have, uh, what we can say, this one, right? So as you can see, for 0 we have what, this destination we have and this destination we have, right? And its price we have given. Okay, what we have given, from 0, if we'll make the adjacent, right, how will come for 0. Let me remove everything. So I'll, okay, see, if I'll make the adjacent, right, for this one, what will come first? It will come 0, right, 0 node, and 0 node will go either this way or either this way, correct? So what we will do, we will add here on the list, right? First we will come this node, right, this node. So we will taking as a list, right? So the whole list will come, this will come, and then this will come. So I'll take a list and that will store like this one only. So at 0 we will have two value we have, right? And this is nothing but a map like this. So this will be our key and this will be our value. Okay. So first time what came? 0 came. This one. It is going this way or this way. So we will select this one is nothing but 0, 1. We'll take 0, 1 and 100. Next entry will be 2, 500. 2, 500. This one. Similarly, we'll consider for what? 1. Next time it will come 1. It will look like what? What we have? 1, 2, 100. It will have 1, 2 and 100 like this. And 2 don't have anything, right? So we'll take like this. 2 is not going anywhere, so it will be, remain what? We can say null. Will not take anything. Okay, by default we'll take null. So this is our adjacent map. This is a key and this is a value. So if someone want to check the possibility, what are the neighbors we have, right? So for 0, there is 2 value we have. We have to move. We have to check with 2 loops, 2 entries. This is our list. This is nothing but our list, right? So in this list we have only one value. In this list is null, right? But this list have 2 entries, right? The first one. I think you have understood, right? Now if we'll talk about this one, right, so now we have distance, right? So for the distance that we have already seen, and this one, so we will maintain our this value. So for all node, like what we have given, 1, 2, 3, 4 we have given. So you can see here, so for all node we have its value. If we'll choose 2, what is the distance we have? So we have 2. If we'll pass 3 as a destination, what we have the distance value, charges 40, like this we will have, correct? So we will have, now we will fill this distance with a max value. Initially max value is nothing but we are taking infinity, as you will see that here we are taking infinity value, right? Here infinity value, let, but in the integer we have integer dot max value will take, and so the max value is 3265 something we have, the bigger value we can say, okay, the very bigger value in the integer. So we'll fill by default this value. Now the best part of this one is we are doing BFS, right? And so that we have to take one queue, right? And from queue we will the first entry we will add onto the queue is let's say this one. We were here, right? In the source we have, right? So once we will come here, let me remove these things. Okay, so once we will come here, you see this one. So we have taken what? Source. What we have taken? Source. And initial value we have taken 0, right? Because we are starting from here, and that's why we have source, we have 1 0, and then we will add one by one. So next time we will add this one, right? And onto the queue, right? So what we have taken? 2. Then its next key is what? 3. Never. N1, this is never, and never 2, right? So we will add this one, right? And similarly we will update our distance like this one, right? We will update. Similarly, once we will finish all this one, so we will update, we have our updated this one, updated distance we have our, right? So this is the purpose that we are doing. We are taking queue and we are adding source and destination from starting, and we'll find number of stops, right? How we'll do that? So first of all we will check number of stops should not be less than equal to k, that is given, right? This should be maintained. And then queue is not empty, then what we will do, from the queue we'll check the size, right? And we'll check if the size is we'll do minus minus, we'll reduce 1 because we are going to traverse 1, right? So what we will do, on the iteration of the current level, let's see, we have at this level that we are talking about, this is at this level, right? Level 1, level 2, like this we have been, right? So we are at this level. So what we will do, we'll check the size, how many we have. From the queue we will take a temp. In the temp we have source and destination, let's say. Okay, like first we came what, 1 and 0. Second time came 2 and 10, right? So what will happen, uh, first time what we have got, 110 and 210, right? Let's suppose. So this is a list. So it will, what will happen, we will put into temp, and then temp at 0 what we have, that is node we have. So for that node, we'll check at what, 1, at 1 what is we have, that is called our distance, right? At 0, that is the node, right? At 1 what we have, that is our distance. Let's say here, if we'll take this one, suppose what we have, this is the node we have, and this is our distance we have, 40, correct? And so that we have to take into our distance, and we will check node and its distance. Finally we'll check on the adjacent, is this node is available or not. If this is not available onto what adjacent one, so we don't need to do anything. Okay, we will not do anything about this node. Okay, now what we will do for all, if we have at the node, right, adjacent node, then we will have our it's all the key, right? I'll tell you, see, 0 we have what, uh, 0 to 1 we have, that 100 we have, right? For source is 0 we have, 2 we have, and 500, like that we have. So for 0 node, we have 2 entries, right? So we'll go for 2 entries. So entry 1 we have given this one, and entry at 0, entry at 1. So first we will take this one, second we will go this one. So if you consider this is E1 and this is our E2, right? So what we will do here, we will do price and distance. It will add price plus distance is greater than what, this one. Say what we have did, what is the price we have, right? Price plus what, or price plus, we have taken what, price plus very price plus distance. See here, if price plus distance, what, if price plus distance, what is the distance we have here? Let's see, price plus distance means price we have given what, for 3 we have some value, right here. So total distance we have here, right? So we have reached there. If that is greater than, right, if we'll do price plus distance, there is some price, let's see, we have 500 and plus, let's see, in the distance, if that is greater than or equal to what, distance at neighbor, any of the neighbor, right? So we will not choose, like we have 100 we have 500 have. If that is greater than, we will not choose that one. We will continue our work. We will do what, distance of neighbor equal to price plus this one. See, because we are updating this one, that here, right? So we will check from here only. We are updating distance at the neighbor is what, price and plus distance. Okay, and why we are passing distance, because for all the distance we have some price, right? And so that to reach at the neighbor, we have to add those values, right? Understood or not? Let's say, uh, come here. First we have what, source we have, right? Then we have taken what, 1 0, right? Next time what is coming, 2 and 10 is coming, either will go here, either will go here, correct? So if we will come to here, right, so what is happening, we are adding 0 plus what, 10, correct? So that's why we are coming here as like this one, right? But similarly, when we come to 3, let's suppose we are coming to this 3, so this will not be 30 only, right? This value should be added, this value and this value should be added, that's why we are getting here 40, right? Similarly we are updating other one. So we'll check price plus distance is greater than or equal to this. If that, then we will continue, otherwise we'll update our uh, distance at neighbor. We will update price and the previous distance what we have, that we will update. Now what we should do here, uh, at each level, once we go to our neighbor, right, at node, so we'll add our neighbor and distance at what we have at the neighbor, that we will pass and we'll add into the queue, right, that we used to do here. You see each time we will take like 335 555 we are adding, right, like this we will do. Okay, once we come to our number of stops, right, once we come to number of stops, we will increment plus plus after completing this whole loop, right, and then we will take if distance is equal to max, right, means we have not find anything but this one, right, we have to return -1. If we don't equal to this value, so we'll pass this value, right. So what we have at the distance, that we will return. And that's all, guys. I think we have covered everything. Let me summarize this one so we will understand clearly. Okay, so okay, so we are here. First of all, what we will do, first of all, we will create adjacent list, and from the adjacent we will fill the max value. After that we will take a queue and we will update the initial value. And for the initial value, what we will do, we'll check the size, and if the size is greater than 0, then we will take its node and its distance, right. We'll check that node onto the adjacent. If that is not there, then we'll continue. Otherwise, what we'll do, we'll get from the adjacent, we will get its entries, its key value. We will pass the key as a node and we will get our values. So at that value, if that is how many entries we have for the key, right, the possible ways from possible flights, right. So possible flight will get, that is nothing but e, right, in the array form. So at the 0 we will get our neighbor and its price is at 1, right. So what we will do, we'll check the price plus distance is greater than we'll check into the what onto the distance. We have maintained our distance, right. And for each distance, let's suppose we are 5, we have here some value, right. Let's suppose like that we have some value, so we will check with that. If not, then we will update our price plus distance, will add into the distance of neighbor. So the next neighbor will come, that will our what we have, let's see, we have price and the neighbor value we have, let's see 5. So this will be 105, right, that we will update similarly. So this will update, we will maintain our distance. Similarly, we will, if we have completed the neighbor, right, so after doing these things, we will do update neighbor and its distance we will update onto the queue. And similarly this loop continue, and once all the entries will done, then we will increment our number of stops is incrementing, right. And once we reach to last, this loop is done, right, all the nodes has been done. So what we will do, we'll check the distance is equal to max. If that is the case, then we will return -1, else we will return distance at what we have, that we will return. Destination, we will pass the distance at destination and we'll return the value. And that's all, guys. So if we'll talk about the complexity, right, so if there is number of node is given and we have a is given and given k is given, right, k is number of maximum stops we can take, right, that. So see, we will have to multiply this one, right. See, we have given ages, how many ages given, that we have to check, and that's why we have to take e into k. Okay, and number of stops we have, number node we have given, so n plus e. Basically, if we want to find the stop and path, so always remember n plus e will become, right. But in this case we have to check the factor k also, and that's why we again n plus e into k factor. So minimum factor, in the worst case it will be the maximum, in the best case it will be minimum. Let's k will be 1 or 0, right. So number of step will be n only. Similarly for the space, we are taking what number of, we are maintaining n, and for all k there will be what adjacent list, and it will take hash map, and that's why we are taking extra spaces like that only. Okay, so guys, please hit comment like for the same video, right. And uh, yeah, one more thing we have left, we have for a space, there is n nodes, and for k we have total cases, right. Thank you, guys, thank you so much.